Hey guys, this is the notes for 4.4, a little homework help. I'm going to go through and just kind of hit a problem out of each section. Let's take a look at question number 7. Look at number 7. We've got 11. I'm just going to use x squared for clarity's sake. X squared plus 2x minus 9. There's a couple of different ways to do this. One, we can kind of brute force it. Obviously 11x squared can only be 11x and x when we factor. But the 9 could be 1 and 9 or 3 and 3, and we would be guessing. So I'm going to leave this for a minute and talk about our other alternative. If we were to multiply, this is sort of my second option here. If I multiply the 11 by the 9, I'm going to rewrite this problem as x squared plus 2x minus 99. Now, we'll talk about what the price of payment for that is later when we get to it. But this makes it easier because I'm not worried about the x squared anymore. It's just x. Now, how do you split 99 so that when you subtract, you get 2? Well, 9 and 11 makes a difference of 2. So I'm going to use 9 and 11 right here. And I'm going to see the subtraction tells me my signs are different. And to get a positive 2, I need a big positive. So 11 will be positive, 9 will be negative. Now, we created this by starting with a multiplication by 11 up here. That means I need to divide both of these by 11. Now, if the 11 divides nicely, like it does here on the right, I can just rewrite it as x plus 1. If it does not divide nicely, 11 does not go into 9, then I'm just going to push the 11 up next to the x to give me 11x minus 9. That is probably the quickest I've ever factored something like that. I mean, it's just clean, it's quick. Yeah, you have to divide by 11 or move the 11 by the x later, but if I come back here now, that tells me that I should use 9 and 1. If I put 9 here and 1 here, I would still technically be guessing. If I didn't already do this other version of the problem, I wouldn't know if I'm right or not. I would have to check by smiling twice. 9 times x is 9x. 11x times 1 is 11x. And then I have to see if that subtracts to make 2. 9 and 11 would subtract to make 2. In order to get a positive 2, I need a plus 11 and a minus 9. In order for that 9 to be negative, I need to put a negative right there and a positive right there for the 11. Notice I get the same answer. One I had to guess and really analyze the signs carefully. The other version just sort of takes care of itself. You do have to remember to divide by 11 at the end, but that's a pretty clean process. Okay, we get down here to questions like 14 and 15. Let's look at 15 real quick. These have these special patterns, and when we look for these special patterns, we're looking for square roots. You'll see similar things with question number 17. With these special patterns, we're really looking and recognizing that we see perfect squares in the problems. So like right here, we can see the 49 has a perfect square. It has a square root, right? And so does the 16. That clues me in that I shouldn't even have to try very hard to factor this. It should factor using square roots. Well, the square root of 49 is 7, so I'm going to use 7n and 7n. The square root of 16 is 4, so I'll use 4 and 4. Because the 16 is negative, the last number is negative, my signs have to be different. So I'll use a plus and a minus. And I'm done. That's called a difference of squares. Subtraction between two perfect squares always works out that way. This one, notice it's not about subtraction, it's about, adding some different terms and they're squared. This also matters, there's 3 terms. This middle guy is just going to be a byproduct. I'm really not worried about him right now. I'm more worried about those first and last numbers. 49 splits as 7x and 7x. The 25 should split as 5 and 5. Now, because I'm not using the multiplication method where I multiply 49 by 25 and try to work it out, because I'm doing this way, I think I need to double check by smiling. 5 times 7 is 35. 7 times 5 is another 35. And sure enough, 35 and 35 adds up to 70. So these numbers are right. I notice that all my signs are pluses, so I'm going to keep a couple of pluses here. All right. When we get to this last section where we're solving equations, a couple things have to really be identified. First, you got to make sure that you have it equal to 0. So if you ever see a problem that's not set equal to 0, okay, that has to be dealt with and fixed first. I always want it to be equal to 0. Once I know it's equal to 0, there's a chance that I might have to make a small adjustment. Like let's look at 33. 33 has 11q squared minus 44 equals 0. Notice that the 11 and the 44 both divide by 11. So I'm going to divide the whole problem by 11 to get q squared minus 4 equals 0. Now q squared minus 4 should look like those difference of squares problems, which means I can use q and q, a plus and a minus, and the square root of 4 is 2 and 2. Now to get the actual answers, I have to pull these numbers out of the parentheses, and when they're grouped with a variable, I switch the signs to pull them out. Q turns out to be negative 2 and 2. If we look at another problem, say like 39, 6r squared minus 7r minus 5 equals 0, it's pretty traditional factoring. I'm personally going to go ahead and multiply my 6 by my 5. If you can factor it and get the same answer as I get by hand and not use this other method, that's fine. But I like this enough. R squared minus 7r minus 30 equals 0. Well, when I factor that, I get r and r. 30 factors as to get a subtraction of 7. 5 and 6 is the first thought, but that's only a subtraction of 1. But 3 and 10 subtract to give me 7. So I'll use a 3 and a 10. Negative 30 tells me the signs are different. To get a negative 7, I'm going to need a negative 10 and a positive 3. But remember, we multiplied by 6, so now we need to divide both of these by 6. So we now have r plus 1/2. Okay, I know there's a step that I'm skipping here right now, and we'd have r minus 5 over 3 equals 0. Now normally that means we're going to bring the 2 over, right? We would normally write this as 2r plus 1, and we'd write the other one as 3r minus 5, right? Those would be our two parentheses if we bring those numbers back over. But remember, my goal is to actually pull the numbers out. And since r's not with that one, like r is separated from the 1/2 right now, it's actually the best time to pull it out. I would get the opposite of a positive 1/2 and the opposite of a negative 5/3. And those would be our two values. Really neat way of getting through that. All right, hopefully that helps you with the homework a little bit. Bring your questions in or shoot me out on Teams and we'll get you taken care of. Good luck. We'll see you in class.